Dominica State College Math 1-to-1 Final Assessment, Section B, Practice Question number 3. It reads, consider the following contingency table, analyzing the relationship between major and mathematics score. So the two variables at play here is academic major and your mathematics score. So this table, what it does basically is give you the opportunity to analyze if there is a relationship or not between these two variables. And it can also facilitate a type of probability analysis, which deals with the selection of one element at random or two or more from this group of individuals. So, but here we are dealing with one selection. So for example, if there is a random selection of one student, determine the following probabilities. So we are going to go to weekly notes number 10, unit 10, for assistance for such a question, such a probability analysis question. To access a unit 10 or weekly notes number 10, we go to CI3QYBO, we go to classwork, and then we go to weekly notes, and we can access the PDF format, but you have the Word, the PowerPoint, and also the video format of the weekly notes number 10. Here it is, probabilities. So here we locate the subtopic analysis of the contingency table involving one selection. So it's like the use of the contingency table for probability analysis. And here you have information with regards. So let's apply this now to our example. So first, before we attempt to answer the question directly, we've got to get the totals, the row totals, the column totals, and the grand total. So here we have calculated the totals, the subtotals, and the grand total, which is 380. So now we're in a position to calculate, for example, what is the probability that this student is from the natural sciences. So that's P of N. Now for this, we are going to use the fundamental formula for probabilities. Here it says that if there is a total number of trials denoted as a sum of F, such that there are some successes denoted as F of X, then the probability of succeeding would intuitively be equal to the ratio of the number of successes and the total number of trials. Hence, the fundamental formula for probabilities is frequency is the successes, right? The number of times that you succeeded over the total number of trials. So that probability values can never be negative and can never be greater than 1. So therefore now, the total number of trials here would be the grand total. So we always use the grand total for probability analysis when we are dealing with a random selection of one element. So our denominator here will be 380. And the numerator now will be how many students from the natural sciences are there. As you can see, there are 190 of them. So the final answer is 190 over 380, which can simplify to a half. B, was the probability that this student is from the natural sciences and scored below 40%. So that would be an intersection. Probability of N intersect L. As we say, the denominator is the grand total. So out of that 380, out of the total of 380 students, how many scored below 40 and are from the natural sciences? There are 35 of them. These numbers here, color-coded in green, are the intersections of the two variables. So 35 students are from the natural sciences and scored below 40. So that will be 35 over 380, which is the probability of obtaining such a student. You don't necessarily have to simplify. You can leave your answer as a fraction. So now we're going to answer, what is the probability that the student scored more than 70 or is from the social sciences? So for this question, we've got to use the addition rule for probability analysis. Let's take a look at it. The addition rule for probabilities in general states that the probability of A or B, or A union B, is equal to P of A plus P of B minus P of A intersect B. So this is the formula we are going to apply. So the probability of A union S is the probability of M plus the probability of S minus the probability of M intersect S. Now the probability of M, oh, by the way, as we know, the denominator will always be 380. So how many scored more than 70? 145 of them out of the 380. How many are from the social sciences? 190 of them out of the 380. And how many? That's supposed to be a plus. Now we put the minus for the intersection of more than 70 and from the social sciences, 60 of them. So that will give us 275 over 380. So now we're going to calculate what's the probability that the student scored between 40 and 70, given that they are from the natural sciences. So again, we've got to resort to a formula in the list of set notation, the list of formulas, algebraic analysis. And this will be formula number 3. P of A after B, or A given B, is P of A intersect B over P of B. So P of B, given that you know that the student is from the natural sciences, and you want to know what is the probability that this student scored between 40 and 70, that is P of B intersect Cn divided by P of N. N here would be the condition. Now P of B intersect N is already a fraction, okay? That'll be over 380. And likewise, P of N is also a fraction over 380. So here you've got a fraction over a fraction because probabilities implies a fraction. Okay, probability of B intersect N, how many are from the natural sciences and scored between 40 and 70, that's 70 of them. How many students are from the natural sciences out of the 380? 190. Here now, what happens basically, the 380 cancels out by virtue of dividing fractions, keep, change, and flip. So the 380 cancels out. So we are left with 70 over 190, which can simplify very easily to 7 over 90. So here is an example of the use of the contingency table for probability analysis.